Hi everyone. In this video, I will be explaining a sample workflow of LangGraph, which demonstrates conditional routing. So conditional routing means from one node based on certain condition, which node should be executed, that will be decided. So let's say, for example, here from this node, based on certain conditions, it will decide whether this node should be executed or this node should be executed or this node should be executed. So this is the most simple scenario, but in complex scenarios, we can execute multiple nodes at the same time also based on certain conditions. So if we are able to pass a condition which wants both of these nodes to be called, then that scenario is possible in LangGraph. So I will be explaining both the simple scenario as well as a complex scenario. So let's go to the notebook and see how this works. So we are in our notebook. First, we will do all the necessary imports. Then we will first define our LLM, and then we will define our structured LLM also using this pydantic class. For LLM, I'm using Grok, which is free of cost. To understand how to use Grok API for free in LangChain, please click on the link in description. And to define the structured LLM, we are defining this pydantic class, which wants the output in this format. The output should be a step, which can be either of these three values and the topic coming the topic of the content generation. Okay, so we simply just call with structured output, and then this becomes a structured LLM. So we define the LLM as well as the structured LLM. Then we define state of our graph. In state, we will save input. We will save the decision taken by the LLM. So which is this? So this will take certain decisions or generate certain decisions. It will also generate a topic. So as you can see, it is generating two things. Decision is nothing but the step, and topic is this, whatever topic the user has input, and the output generated by either of these LLMs. So the state has been initialized. Now we have the three LLM calls. So if the decision is a story, then this LLM will be called. If it is a joke, then this one will be called. If it is a poem, then this node will be called. Okay, and this is our LLM call router, which will take the user input and it will return two things because we are using a structured LLM here. Here you can see the difference that here we are using simple LLM from LangChain, but here we are using a structured LLM, which will return output in form of step and topic, where we have provided the instructions and the user input will be provided. Okay, so these two fields will be generated. This is the router function. So router function, if the decision is story, then this LLM call one will be called. If it is a joke, then this one. If it is a poem, then this one. Okay, so let's initialize all our nodes and the router function also. Now we will build the workflow. So we start with state graph. We define all our nodes. So these are all the nodes that we have to define. Then we define our edges. So this is one edge where it is a fixed edge from start to LLM call router. And these are also fixed edge. From each one of these, it will always connect to end. And this is the conditional router. Okay. So conditional router, what we have to pass is what is the starting node, what is the router function, router condition, and then what is a mapping. Although this looks a little redundant here, and it is redundant indeed, but if we want to show labels here, then we can pass the values accordingly. So here we will have to change it. So we pass, instead of LLM call one, we pass story, we pass joke, we pass poem. Okay, so we run this. Now the output of the router function will be different. So that mapping we will have to create. So first is story, then joke, then poem. Okay, so now if I run it, then you can see the label will also show in the graph. You can see here, these labels also show. So that this makes the graph more intuitive, that what exactly, under what condition this route will be called, and other two also, right? So now we have the graph set up and it is compiled also. Now let's try to run a few examples. So we will try to just invoke with this input, write a joke about cats. So this is the decision or the step that we want to take, and this will be the topic. Okay, so let's see what output comes. So here you can see the decision taken was joke, topic extracted was cats, and then this is the output generated. Okay, so if we try to stream it also, we will be able to see what nodes got executed and in what order. So first LLM call router was called, the decision generated was joke and the topic was cats, and this is the output generated by LLM call 2 here, right? If you can see, this was called based on the condition. The condition was decided by this. Okay, so this is the most simple workflow where we only go to single node based on conditions, but we can make few changes in the graph or in the code so that we can try to execute multiple nodes also based on the conditions. So what changes we have to make, I will show you here. Okay, so first change that we have to make is that we have to change the router schema. So here earlier we were simply asking for a literal, which will always return single value. Okay, but we change it to a list of literals. That means it will always return a list in form of steps, and the list can have only one of these three values. So it can be poem and story also, it can be story and joke also, it can be all three also. The topic will remain the same. So here we define our router LLM. Then in state, what changes we have to make? The decision earlier was a string because we were just taking a single value in the decision, but now we will be passing a list in the decision. Okay, so this change we will make. Next is the output. Output earlier was a string because we will simply saving the output, final output generated by either of the nodes. But now we will be saving the output from all the nodes. Okay, for that we will use a reducer or reducer. uh, what it will do is that we are defining a dictionary here as output, and it will be the key will be a string and the value will also be a string. But what this will do is that when multiple nodes run and both of them save the output in this node, in this field, then it should both the values should be saved. If we don't do it like this, if we simply pass a dictionary, either it will error out or it will overwrite the previous value. It will not save both the values. Okay, so that's why this reducer is important. So this is a new concept to learn here. So, and which is very important. So this is another change. Then we change the content that we want to send from each LLM. Earlier we were simply sending the result.content to the output. Now we will send outputs in form of a dictionary. So whenever we use a reducer, whatever is the type of that field, in that form only we have to send that output. Okay, so here it is a dictionary, so the key will be story and the output will be, the value will be result.content. Here also earlier we were simply sending this, but now we will send this dictionary where joke is the key and this is the value. Here poem. And so what will happen is that if multiple nodes run, then a dictionary will be saved in the outputs having multiple. Let's say if we are running based on conditions LLM call 1 and LLM call 2, then this output will have a dictionary of two keys. One key will be story and corresponding value, another key will be joke and corresponding value. Okay, so this is a very important change. Now the router, LLM call router also we have to change. So earlier we were simply taking this step and topic, but now we are asking to generate all the steps in form of a list and then the topic. Topic will remain same, but the decision will be a list. Okay, so this is a change. Then we do fan out routing. So fan out routing, what it does is that here if you see, the return value is a string, okay, based on the conditions. But here the return value is a list based on this mapping. So the values in the decisions will be a list, and whatever values are there, based on that we will return corresponding LLM. So this will return a list of nodes to be called, okay, rather than a single node. So remaining here, there will be no change, and here also no change is required. We will simply just define it, and it will decide if it is returning multiple nodes, then multiple nodes will be called, and you will see how it works. Okay, so this is also the same. Then we try to display wise it will all look the same, but when we run it, you will see that multiple outputs are generated. Here joke and a poem is asked for about cats, so in the decision these two values will be saved. So I'm streaming. So just to tell you that, just to explain how it is running. So first this is called, and the decisions are joke and poem. Cat is a single value. And here, based on these two values, these two nodes are called LLM2 and LLM3. And these are the outputs. If we try to invoke it also, we will see that both these output of both these is saved in the single outputs dictionary. Okay, let me run this. See, this is the decision, which is a list, and output contains a dictionary of two key value pairs. One is joke and one is poem. Okay, so this was a really important change that we tried, which helps us understand how complex conditional routing can work. So that's all in this video. Please let me know in comment section what more videos you want to see, and please subscribe to my channel. Thank you for watching. Bye.